frozen surface of Enceladus, and its surface is frozen much as the surface of Europa is frozen. But underneath that frozen surface, again, there is liquid water and organic compounds, organic chemistry occurring. And in this case, Enceladus is releasing some of that material to space, so it's even possible to fly through those plumes, and the Cassini spacecraft has done that, and tell us about the composition of those plumes, which you see coming out right there. And then finally, on Titan, a large moon of Saturn that has an atmosphere, we have discovered a moon with liquid on the surface and a hydrological cycle of liquid on the surface, evaporation, cloud formation, storms, rain falling back down into rivers, which then drain out into low-lying areas. But the liquid is not water. The liquid is liquid methane and liquid ethane, effectively liquid natural gas, the kinds of gas that you may very well use to cook your food or heat your homes. So this opens up an entirely new set of possibilities for life. Could there be life in which the solvent for life is not water, but the solvent for life is liquid methane or liquid ethane? Now, there are some very interesting scientific ideas about that, which I won't have time to go into today, but there is literature about that, and if you're interested, I can refer you to where there's some articles about that. So, the third area of science that was just actually beginning in the mid-1990s is our understanding of planets around other stars. The very first planets around normal stars were announced in November 1995 by the group in Switzerland, and in March 1996 by the group in the United States led by Jeff Marcy at that time. And since then, the so-called radial velocity technique, in which you look at the motion of a star caused by the gravitational attraction of a planet surrounding that star, this requires that you measure the spectrum of the star extremely accurately, and you can then measure the absorption lines in the stellar spectrum, and you can see how those absorption lines change their wavelength very, very slightly, shifting to the blue, of course, when the star is moving toward you, and shifting to the red when the star is moving away from you. Now, the reason the star is moving is simply if there is a planet surrounding the star, it is not that the star is stationary and the planet is simply going around, but as you know, the entire system is actually rotating around the center of mass. But because the star is so much more massive than the planet, the center of mass is very close to the center of the star, but when the two bodies revolve around the center